A robot just shook hands with a human, without breaking any bones. That sounds simple, but it's actually one of the hardest problems in robotics. The ALLEX humanoid, built by South Korean company WIRobotics, can detect forces as small as 100 grams, about the weight of a smartphone, and respond instantly. Its fingers deliver 40 newtons of force when needed, but can dial back to a gentle touch in milliseconds. This is the breakthrough that could finally let robots work alongside humans without safety cages. WIRobotics is a South Korean robotics company that's been working on wearable assistive devices, but at CES 2026 they showcased something much more ambitious. ALLEX, which stands for All Experience, a general-purpose humanoid robot with what they call whole-body force control. Here's what makes this different from typical industrial robots. Most robots use position control. They move to exact coordinates and stop. If something's in the way, too bad. That's why factory robots work behind cages. ALLEX uses force-based responses instead. It can feel resistance, detect contact, and adjust in real time, without needing expensive force sensors at every joint. The technical specs are impressive. 15 degrees of freedom in each hand, fingertip precision of 0.3 millimeters, and the ability to handle 3 kilograms with one arm, while weighing only 5 kilograms from shoulder to fingertip. For context, that's the work capacity of collaborative robots that weigh over 20 kilograms. NVIDIA, Meta, and Amazon all expressed purchase interest at the show. WIRobotics has also partnered with MIT, the University of Illinois, and physical AI startup RLWRL to develop the robot's intelligence further. Force control is the invisible line between robots that work near humans and robots that work with humans. Think about what happens when you hand someone a coffee cup. You feel the weight transfer, you sense when they've got it, you let go at exactly the right moment. That handoff requires constant force feedback, something robots have historically been terrible at. This is why humanoids keep getting stuck in controlled demos. They can walk, they can pick things up, but the moment they need to physically interact with a person, helping someone stand up, handing over tools, working in tight spaces, they become dangerous. ALLEX's approach of building compliance into the hardware itself, rather than relying on sensors and software to compensate, could be the architecture that finally solves this. If humanoids can safely touch humans, suddenly elderly care, physical therapy, household assistance, and collaborative manufacturing all become real applications instead of PowerPoint slides. WIRobotics says they're targeting 2030 for a general-purpose humanoid that anyone can use in everyday life. That's ambitious. The immediate question is whether this force control architecture can scale to full-body movements, walking, catching yourself when you stumble, carrying heavy loads through a house. Watch for real-world pilot programs, not just trade show demos. When hospitals or manufacturing plants start testing these robots with actual patients and workers, that's when we'll know if this technology is ready to leave the lab. Robots that can finally touch without crushing. It's a small thing that changes everything. If you want to stay ahead of what's happening in AI and robotics, subscribe. We break down the stories that actually matter. See you in the next one.